Hello everyone, welcome to the next session of the Alam Bradley PLC series. So in this session, we are going to design ladder diagram for all the logic gates, so that you can able to improve your logic as well as you can able to implement uh, that particular developed logic for the upcoming projects. So as you all are aware about the different types of logic gates, that is AND gate, NAND, OR, NOR, NOT, XNOR, and XOR gate. So here I have already provided the description and the essential things for designing the logic gates. So here you don't need to find out the two tables and their expressions. So everything is here. Your task is just to learn the concept and implement for the upcoming project. See here, initially let us start the logic gate with the AND gate. So as we know that, for example, if you are designing the project, like you have to turn on the motor by using two inputs. It means that when you are pressing the two input, then and then you will get the turn on operation from your motor. So that is possible only by using the AND gate. Means the AND gate is useful for the series operation. Like see here, the expression for the AND gate A dot B equals to 1, right? So A and B both are the inputs. So let us consider A and B both are the switches. And Y is nothing but the output. So output may be anything, right? That may be that is the digital output. That may be a motor, pump, footer, indicator, anything, right? In order to execute this operation, you should know the truth table of AND gate. So this is the truth table. Here you can see if both the inputs are pressed, then and then we will get the output. And for the rest of the cases, we are not getting the output. Remember, see here, as we are considering A and B both are the switches. So initially, that two switches, here it is like this. Here I am selecting the two switches like this, right, with normally open contact. Now provide the address. For example, here it is. You can check. Let us consider this is the switch 1 and this one is the switch 2. If you want, you can go with the push button also, but for the push button, logic is little bit different. In upcoming session, I will cover the logic for push button. Now here it is, I have added two switches so that I can able to turn on the output. Now I have selected the output and providing the output like this. Here I have just provided the name output y1. This is just for your understanding purpose. Right? If you want, you can provide any output name like motor, pump, footer, anything. And compulsory, you have to connect that output on field also and to that particular terminal. Means to the zero terminal, your output will be connected. Right? Now, this is how you have to design AND gate operation. Okay, series operation also. Okay, we can see series operation also. Now coming to the next operation, first of all we are just going to design it, and then after completing the design process, we are going to run it and verify it. Now coming toward the OR gate. In the OR gate, you can observe as and when we are going to perform the parallel operation, use the OR gate. Means you don't need to mention here we are using the OR gate, no need at all, right? This is just for the understanding purpose, right? So while learning the rules of the logic gates, we have already used some parallel operations. Means we can use the number of inputs in parallel as well as the output also. This means that we have connected number of inputs and output in parallel. Okay? So it means that we have used the OR gate operation here. So this is the truth table for your OR gate. Means whether, so whatever the logic, the ladder diagram which you have designed, whether it is right or wrong, so how to know it. Okay, so for that purpose, we have to refer this truth table, right? Means we have to verify the truth table with the design ladder diagram, right? So simply we have to select normally open contact and one rung branch. Rung branch means what? It is useful for connecting the number of inputs and output in parallel like this. So here I am using the same inputs, as we know that we can repeat the number of inputs so many times on input side like this. We can drag and drop it like this. But we cannot repeat the output address, so we have to provide another output address like this. Okay. So for your understanding, I'm changing the name like this. This is the motor A, right? This one is the motor B. Okay, so we are using these two motors for the different operations, right? Now, the one more thing, this is the edges part, right? So similarly, if you have to design the NAND gate, so how to design it? See, here I am just using the copy paste instruction in order to save our time. Just copy and the paste. Here you can see copy paste instruction, right? Now what I'm going to do here, I'm going to tell you the ladder diagram for NAND gate. So if you are designing the ladder diagram for the NAND gate, in that case your operation will change because your expression will change. Dot means what? The dot indicate the series operation, always remember. And the plus, okay, I'm showing you. The plus means what? The plus indicate the OR gate operation or the parallel operation, right? So here, now, for the AND gate, your expression will be like this. A bar plus B bar. So this is the expression for NAND gate. So obviously for the NAND gate, our operation, that will be parallel operation, right? That will be parallel operation. It's very simple. Okay. Then click on OK. So before that, there will be change into table also, right? So here your truth table, that will be like this. So for the 1 1, your output will be 0. For the rest of the case, your output will be 1 1. Okay. Now how to design it? See, initially we have just used the A and B, like switch 1 dot switch 2 equals to motor, right? But here A bar is given. So what is the A bar? The A bar means what? So instead of using the normally open contact, we need to use normally closed contact in parallel, right? So delete it and use normally closed contact. Because the A bar is here. For the A, we need to use normally open contact. For the A bar, we need to use normally closed contact like this. Okay. So I'm using the same input address. Right? Same input address. Okay, so for example, here I'm telling you one trick like this. For example, if you have selected normally open contact and provided the address also, and suddenly you got to know that instead of using the normally open contact, we need to use normally closed contact. Simply click on it and right click and click on then select the change instruction type. So XIC means what? XIC means examine if close, right? So instead of that, just type examine if open and click enter. Now your contact will become a normally closed contact, right? Now here you can see the outputs are repeated. So let me change the output like this. So again the repeated, let me change this also because we cannot repeat the output address. So instead of this, I am providing the description to this motor C. Okay, motor C like this. Now here you can see this is the ladder diagram for NAND gate, and in which you can observe the parallel operation. For the OR gate, your ladder diagram will be like this. But for the NOR gate, your ladder diagram, that will be different, right? So that will be like this. Let me copy it. Okay, NOR gate. Your expression will change. Okay, means if you are writing the expression A plus B whole bar, then your expression will change like this. Means the A bar dot V bar. So dot means what? Dot means this is the series operation. Series operation. And the truth table will also change like this. So this is the truth table for NOT gate, right? Means when both the switches are pressed, in that case your output will be 0, right? For this also, but when both the switches are open, in that case you can observe the output. Let us see. Okay, now we have to change the ladder diagram. So how to change it? It's very simple. Now just use the close contact in series. Examine it. If you want, you can use the different switches also instead of using the same switches. Okay, so you can go with switch 1, switch 2, switch 3, switch 4 like this. Okay. Now coming toward the next gate, that is nothing but the XNOR. Okay. In case of the XNOR, you can observe while designing the projects, if you are using the XNOR gate, so in that case you have to take care of few things. In the XNOR gate, we are using parallel operation as well as series operation also, because you can observe the expression. In the expression, dot is given and the plus is also given. It means that it consists of parallel and the series operation. Okay. Now it's very simple. Here I have written everything. Okay. Normally, examine if close means normally open contact. Okay. So I have provided the meaning just for your more understanding purpose. AC contact. If it is green, then we can see off state. I will show you when we are in running mode. Then the normally open contact not green, it means that off state. Here it is. You can see normally open contacts are here and not green. Okay. This means that these contacts are in off state. Okay. Now coming toward the XNOR gate, it's very easy. You just need to follow the expression. A bar. A bar means what? Normally close contact. Dot means what? Series means whatever the input which we are going to connect after this A bar, that will be in series because the dot is here. So again the normally close contact. So here you can observe A and B, only two inputs are here. Okay, don't even think about the 1, 2, 3, 4 means the A bar, B bar, A and B means total 4 inputs are here. No, only 2 inputs are here, but only its contact and the symbols are changed. Okay, so A bar means here we are using the A and A bar will be same, means in terms of address. The B here I have provided, and the plus is given. Plus means what? Here we need to use the parallel branch, or we can see run branch also. And A dot B means normally open contact. Normally open contact. Right? Now I am using the output file. Now randomly you can select any output or any terminal to which you are going to connect your output. Right? Now this is the motor D. This is the motor. Okay. Now coming toward the last gate, that is nothing but the NOT gate. The one more gate is remaining, that is nothing but the XOR gate. So we are going to use that XOR gate in the upcoming projects, right? Means not only these gates are helpful for designing the project, it will be helpful for understanding the logic concepts in the LM Bradley PLC as well as in other PLCs also, right? And this is a very important part. Okay, now the last one, that is nothing but NOT gate. Okay. NOT gate. In NOT gate, you can observe the only one input and one output, right? Now, if the input is 1, then output that will be 0. And if the input is 0, means not pressed in or in off state, your output will be 1. Because the expression that will be like this: A bar equals to Y. It's very simple. Now, here I am using, okay, let me copy it. Now you can paste type data over here and output. Here I am just using the switch 1 and output that will be again motor. So here I'm providing the tag motor D. So always remember, cannot use the same tag name in the alumni list. Tag name is what here. If you are providing the motor D again, it will not be acceptable, right? Here, if I am typing here motor D, so here you can see it is not acceptable, right? Now here almost we have designed all the logic gates. Verify the file. Now here on your left bottom corner, you can see no error. It means that we can run the program now. Click here. Here you can observe go online, download and upload. See, if you have designed the program and you have downloaded that program once, and if you go to the offline, right, and if you want to run that program again without making any change, okay, so simply in that case you can click the go online. Means you don't need to click on the number of pop-ups, okay, and directly you can go online if you are using the go online. Now upload means what? For example, you have already downloaded the program in your PLC, and unfortunately you have deleted that program, and if you don't have that program, and if you want that program again, simply you can upload that program from the PLC. Okay. Right now we are just using the download. We want to go online as right now we are in the remote program mode. It means that you can just verify, you can just monitor the program, you cannot even edit the program, not even run the program. Now again click on it, and here you will get a number of options. Among that, just select the run. Now our task is to verify all these design ladder diagram as per the truth table, right? See, if both the inputs are in on state, your output will be on, right? And for the rest of the cases, output will be 0. See here, switch 1, here I am pressing the switch 1, means this is the state, second state, 1, 0 means 1 and 0, output that will be 0. If both the switches are in on condition, then and then we are getting the output, because if you are not pressing the any switch, the current will be blocked here and cannot able to start the motor, right? So for that purpose, we have to press both the switches, right? Means we have successfully verified the AND gates. So similarly, we need to verify the rest of the gates also. See here, now coming to the NAND gate. In NAND gate, you can see we have already pressed switch 1 and switch 2. Here you can see switch 1 and switch 2 already pressed. Don't ever think about the colors here, right? If you are not observing the color surrounding this normally closed contact, this means you cannot consider, you cannot assume that the current is not flowing through this contact, right? So here we have to consider the initial state of the switch 1 and switch 2 in normally open contact, right? Now here you can see when both the switches are in on condition, like this, on, right? Both the switches are in on condition, okay, but here if you are not able to understand whether these switches are in on condition or in off condition, simply you can refer the data file. Go to the data file, or in data file you can observe input 0 or input 1, means input 0 and input 1, that is in on condition because 1 1 is here, okay, 1 1 is here, and output is in off state. So if you are releasing any input, for example, if I am releasing the switch 1, then you can observe the operation of motor, means this is the state 0 and 1, okay, and if I am releasing both the inputs, means if both the inputs are in 0 state, then and then you can observe the operation of your motor, right? Means we have three different stages in the NAND gate in which we will get the output from the motor. Now coming towards the NOR gate, OR gate, sorry. Okay, and one more thing which you can observe here, you can observe some blinkings, right? Because we have repeated the output address, right? This means that we are not using the rule for this program, right? So simply go to the offlines here, again click on the download arrow, go offline, say no, and change the output address, right? So here 2, here output address that will be change. So here I'm providing the 4. So motor. So you can provide any description. No worry. Now again go. Now here we have used the proper ladder rules. Okay. Now coming toward the OR gate. In the OR gate, you can see both the inputs are connected in parallel. If you have given a task, for example, if you are facing the interview and the task is that you have 2 inputs and using that 2 inputs, we need to turn on the motor. Okay. The first condition is that we have used the 2 switches, but instead of pressing the 2 switches, if you have pressed only one switch, then also motor should operate. Okay. And if you are pressing switch 2, in that case also motor should operate. Okay. So simply use the OR gate. Yes, here. Now here I am pressing the switch 1, motor gets on. Here I am releasing the switch 1, motor gets off. When I am pressing the switch 2, then you can observe the motor is turned on, right? If I am pressing both, then also you can observe the motor is on. Okay. So if you are thinking how this happened, because the current flowing through the parallel branch here, current is flowing through the parallel branch, that is the reason motor is operating. Now coming to the NOR gate, in NOR gate we have to follow the truth table again. So here you can see if both the inputs are in off state, then and then we can observe the operation from motor app. Okay. So here you can see we have pressed the one input, then release it, right? Okay. So now here we have pressed both the inputs. Means it means that it is the first stage. Stage means 1 1 0. Okay. If I am releasing it like this, then you can observe the on state of your output, means the motor is operating now for the last stage number 4, 0 0 1. So we have successfully verified the NOR gate also. Now coming to the XOR gate, in the XOR gate you can observe the state when both the inputs are in on condition, we will get the output, and when both the inputs are in off state, then also we will get the output. And for the rest of the 2 cases, we are not getting the output. Means as per your requirement of your project, you can use all these gates. Means in that case, even if you don't know the logic gates, and if you are a skilled programmer, so whatever the ladder diagram, that will be similar. It means automatically create like this. But if you know the logic gates, so we don't need to think about the logic also. So directly we can design the logic and it will be fixed to our program. Okay. Now here you can see again we are using this truth table. So now here you can observe the state. Okay. It means that 1 and 0. So for the 1 and 0, your output will be 0. For the similar, so both the inputs are in on state. So these are the on state and these are the off state. Okay. So the motor is turned on or operating. And if both the inputs are in off state, both the inputs are in off state, in that case we can see the current is flowing to the close contact and our motor is operating. Okay. So we have successfully verified the truth table. Now coming toward the next one, NOT gate. It's very simple. If the input is 0, here you can see the input is 0, close contact is green here. It means that the input is 0, his input is in off state. So your output will be in on state. It means the motor is operating here. If the input is 1 or your input is in on state, your output will be 0. Means your motor is not operating here. So if you want to go offline, so simply click on the go offline, save no, because if you click on the save as, so whatever the changes which you have made, that will be saved in the program, so which I don't want. Click on no. So this is all about this session. In the next section we are going to discuss about the project number 1.